Craig Maloney. He's going to talk about Pygame.
Talking about Pygame. How many folks have ever dreamed of being a game designer, developer type person?
No.
And doing video games? No! Well, by the end of this meeting, you all will want to do that. Or I will have failed miserably.
Be able to do it.
And you'll be able to do it. You may not have the desire, but you'll be able to do it. So what we'll cover here is we'll cover a little bit about Pygame, what it is, how to get started. We'll talk about events in Pygame and how they work. Talk a little bit about getting some rectangles and images on the screen, some of the drawing primitives that are a part of Pygame. Talk about sprites. Remember back in the 8-bit days, there were like hardware sprites and that. Now they're a little bit different than that. And we'll talk about completed games because I ran out of time. But we will not. Oh, hello. Okay. I've got some links here. First off, the Pygame site is an excellent resource. There's plenty of source material out there on the Pygame site. Lots of example games. There's 2 books that are really interesting. The first one is Making Games with Python and Pygame, which is a Creative Commons licensed book available completely for free and also in paper form. It's the one that I would highly recommend. There's another one by the same author called Inventing Games with Python. And it's a little more geared toward kids. I won't hold it against you though if you decide to pick it up and check it out because it is still good. It's just a little more on the, you haven't done any programming and you're also 12 level. There's the program Arcade Games with Python and Pygame, which is also excellent. It covers more sprites than Making Games with Python and Pygame. They don't cover any of the sprites, which you may see why in a little bit. And there's also a competition called PyWeek, which is a week-long competition. It's held twice yearly. It is a week to take a game from concept to production. And I did it twice. I haven't done it since. I finished 1.5 times. And you'll see some of the results of that. So what is Pygame? Pygame is a framework for adding graphics and sound under the Python. It is over SDL, which is a simple direct media layer, which you may be familiar with. It was developed by Loki Software back in the late 90s. Rest in peace, Loki. But basically their work in porting games over to Linux created a really great framework that is still used today. It is portable everywhere that Python and SDL are running, and it is also optimized. Uses C and some assembly underneath, which makes it kind of a pain in the butt to use under virtual env, if you know what that is. And it is simple. Even I could procrastinate the entire week and come up with something functional. What it is not a direct port of SDL. For anything that's a little more complicated, you may want to use PySDL for that. It is not OpenGL specific. You do not have to have an OpenGL card. It uses 2D. You can use OpenGL with it. What it does is it creates, for lack of a better word, a canvas, and uses OpenGL to draw upon it. So it creates a surface that it draws on. It is not GUI dependent, so you can use it for, if you like the event stuff, if you like the event handling, if you like the sound libraries and that, you can use it with that. And it is also not stagnant. The last release, thanks Ben, was in 2009, and but they're still working on 2.0, so they're doing some updates. I haven't followed the development that closely, so if you ask me about 2.0, I will deny all knowledge. But it is progressing. So what we're going to work on is an old Activision game called Kaboom. For those of you who are not familiar with Kaboom, it is a game designed and developed by David Crane. Back in the 1980s, it ran on just about everything back when. Used paddle controllers. What you did was you were the little bucket down here and you tried to catch the bombs that were falling overhead by the Mad Bomber. So let's get started and do some development.
An Atari 800, wow.
That was my computer. And that's, for those of you who don't know who that is Chris Crawford. He's one of my game designing idols. So let's take a look here and see what we got. So
Do we get
Well, you can have problems.
So can everyone see that?
Mm,
No, of course not. Of course not. Let me open up another terminal here. Let me go into the other directory. All right. It's always the uncomfortable pause. Let me actually CD into the directory. There we go. Does anyone know any good jokes?
Pretty terminals.
I want to play them.
Do you like terminals? Terminals are sweet.
All right. Oh, that will teach me not to do that right here. All right. So let's start off. This is an extremely simple Pygame program. What it does, we created a rectangle up top, about 800 by 600. We have a main loop, which initializes the Pygame, creates a display, and then sits in this loop right here, and says for every event we get, we have one event that is special called quit, and what that event will do is whenever we exit out of there, it will clean up and do its stuff. And it looks a little something like this.
Awesome. What is that for?
So, hello world in Pygame. Not a whole lot of interesting stuff going on there. Let's move on, if we shall. So I will check out. So this is probably a little more interesting. I'm going to do this in the window instead. All right, so we're going to start off with a sprite, and what that will do is that we're creating a class called bomb, which is a sprite, and we're telling it where exactly to do a position. There, and if we go here, we got a little more into the sprite. So what this will do, and let me do a quick run on it in the interest of time, is it will create a circle. And what that circle will do, give it a position over here, XY position, tell it the size. We'll draw a circle inside of that. We'll add the sprite into containers. Containers are a list of all the sprites that are in there as part of a group. And you'll also see that I added some additional stuff as far as like a background fill, which doesn't work in this particular checkout, and that's because I had a bug in there. We told it to position it over at position 4040, which is over in the top left corner. Because on any screen, you start off from 0.0 up in the top, and it goes down all the way to 800 by 600 down here. Sort of like a text screen, you say, okay, the top position will be up there, etc. All right. And what it is doing is this loop is continually going through, and it's finding all the events. It's going through. We added the sprite to an all container. Thank you. We do a clear of the screen first. We update, which then calls the sprite's update routine. We find all of the dirty rectangles, and we redisplay them. And you'll note this little FPS clock tick. That's frames per second. In order to make sure that this thing doesn't run as fast as your computer, it tries to pause it a bit and let it breathe a little bit. Sort of like a fine wine, it lets it breathe. And we tell it to do so every 30 seconds. Check it out. This is going to get a little more interesting here. So now we have something that actually falls down, and that is in this code here, where you have the update. And the update will say take the y coordinate, add a speed to it, and then have that drop down and redraw it every single time. So every time the frame comes up, it reruns that update, adds the speed to it, and then sets the falling speed for it. Promise this will get much more interesting. All right. So now that we have that particular sprite, we set an alpha on it. Because before you had the little box around it, that's not pretty at all. That's ugly. So we set an alpha channel for that particular thing. The alpha channel is up in here. Up in here. So we set a source alpha on there, which is basically a flag to say make this particular surface a alpha surface, which allows it to then be transparent. Now you can see that we're 8 commits in roughly, and we have a falling bomb. Let's see what else we got here. We're not that far from the end. How far did I get? Who knows? So in here we added the bomber. And the bomber uses a drop bomb event. And what that is, you have different user events that you can set in this. So what I did is I set an alarm on there that says every X number of seconds, X number of milliseconds, I tell it to drop a bomb. And I created a little formula here every 2,000 seconds, minus the self madness times 60. Madness is basically the level that I have. Drop a bomb, okay? And so you get this little cadence of him dropping a bomb. He figures out how many of these actually dropped, and then continues. So you have the set bomb timer, which sets an event timer that continually loops through. And then he drops the bomb whenever he hits that. And the event is handled down in here. We have the event type is of type bomb. Tell the bomber to drop a bomb. Okay? Any questions so far? I know I'm going a little fast. As I said, it was a quick introduction to this. Right? So that was a little quick. So you use the events to drop it in a nice rhythmic pace. Well, apparently that wasn't very rhythmic, now was it? Well, it was rhythmic. Just a little quick. You could have all caught that, right? Yeah. All right. So that was to get him to change the direction. So he has a little timer built in here that says anytime that he needs to change the direction, he will do so. And I set up a separate event. It's a user event plus 1. Every event that I set up that is user specific, I create a user event, and then I keep adding a 1 to it. You have a certain number of events that are available to you in Pygame, from user event to num events. So you can check and see how many events you have that you can use. Yes?
When you say it's a user event, it's more like an AI, right? But it's called a user event?
It's called a user event because it's user specified. So it's something that you yourself can specify. So if you wanted to create a different...
You being the developer.
You being the developer, yes. That's what I mean by that. Okay? Check out this one. So this is a little more logic to the bomber itself. So we have a number of bombs that he's dropped. We have the update. We have the timer for when he's going to set the bombs off. We have the handler for when he's actually dropping a bomb. changing the direction. You see what he does here. So now he's going to be a little more slow about it, a little more groovy about this type of dropping. And I think this one actually will do the levels. So when he actually finishes doing his dropping and that, it'll update the level. Let me check and see if that's true. Okay, I don't think I got quite that far yet. Fix the sprite collision confusion. If I'm not mistaken, this also introduces a floor. Now, when these bombs drop, now let me set this up so that you can see it while it's going at the same time. When those bombs are dropping, okay, I actually added another event too where you do a space, it'll start dropping. When these are dropping, these will keep dropping forever unless they actually hit something. And this is where we started introducing collisions. As you can see, right as they hit the bottom here, they disappear. That is because we set a collision, and the collisions are handled down in here. Now I haven't shown the containers part yet because it wasn't interesting. This part is actually interesting. We have a bomb, a bomber, and a floor. And each of those are all part of the all container, but they're also part of themselves. Don't ask me a whole lot about the sprite containers, and I don't know a whole heck of a lot, but what I do know about them is that you can set up a list of collisions. So I set up a collision group between the bomb and the floor. When the bomb and the floor hit each other, this is returned. There's a bomb and floor. And I don't actually have it printing out that at this point. But if you have a list of collisions, so every time that you have a collision here, so when this hits, this bomb and this floor, this bomb and this floor, this bomb and this floor, etc. And it will return that. And what you can do from that is you can say, okay, first off, the bomber, we let him know that something has happened, that the bomb exploded, so then he can say the number of active bombs is less. For every one that we hit, we have it explode. And unfortunately, I kind of punted on this one. Because the update, first off, it passes, and there's not really a whole lot going on as far as the explosion. It just kills off the sprite. Normally, there's a default mode which will actually destroy the sprite down here. You see this false here? That actually you can set that to say, okay, this will actually kill this particular sprite. If there's nothing that you really need to do with it, you don't need to call anything, you just need it to just go away, that will do that for you. Any questions so far? All right. So this is a little more tweaking on this. I'm going to actually skip the tweaking. This is all available on GitHub if you want to see some of the thought processes that went behind this. It's just basically me trying to figure out how to make the bomber work a little bit better, how to make it slower. I'd say when I finally finished this, I got about 40% of the way done from a complete game. Okay, now what makes this one interesting, I'm going to run this and then I'll show you the code. Now if you've ever played the game Kaboom, what happens in the actual game is when this explodes, each of those bombs explode in turn from the bottom up. Rather than actually figure out which bombs were in that particular list and then do it, I moved the floor. Because the floor, once the floor will finally clear off everything, there's already collision in place, for it. So each of those bombs will then get removed, and then I'll have a clear slate. It's kind of like the pen machines, you know, just kind of clears it. Now, if I were to do this over again, I wouldn't have done that because it made my life hell trying to figure out what determined an actual floor collision versus what was clearing the screen. So I did a little fancy stuff in order to get around that. That collision is handled here. So I added another time event for the bomber to wait. So when when everything is exploding, he waits a few seconds before he starts dropping bombs again to give the player some time to consider his actions. The floor movement. The floor movement is, most of the time it sits completely still. If it's exploding a bomb, then it will move the floor up 3. So 3 pixels, it will move the floor upward. And that's handled here where it's doing it's subtracting the speed from the y-axis, from the y position. Okay? Now, it's not really that, it's not preferable to actually show the floor moving, because first off, it doesn't make any sense. Why would the floor move? The floor is just static all the time. And what I did there is I set the floor to be an alpha channel, so it's invisible now when it actually hits. Hit the space bar. So now we have most of the things to our game, except we don't have a player yet. And I'm only 2 commits away from the end of this. How does that work? Glad you asked, hypothetical user. So here we have a player that can be moved around via the mouse. How does that work? What I did, there's the player. That's it, in its entirety. And you may say, wait a minute, there's only 1 rectangle, and I'm seeing 3 rectangles. And you may also say, wait a minute, there's not a whole lot here as far as like updates. All I'm doing is I'm figuring out how far he can go on the margins. But there's no, that's not like the bomber. He doesn't have any events that get called. Why is that? And the reason being, due to the magic of Python, and I probably could have done this in Pygame itself, but I chose not to because I went with what I know, is I instantiated the player up here. So the player sprite gets instantiated as an array. I then create 3 separate players. Each of those has a collision capability that gets added up in here, and each of them gets the collision tested down here. So if the bomb hits the player, the bomb is then diffused, which basically kills the bomb. You could use it for scoring and that type of stuff, but I didn't get that far. And then the bomber knows that the sprite has been diffused, so it says, okay, that's no longer an active bomb, carry on as usual. So what does that look like? I'm just going to leave it here for the time being. Okay? So then you have the boom. And then when he gets reset, I actually pop the player off of here. So if he...
Now, if you catch the bomb with the second player or the third player, does it still defuse the bomb?
Yes. It's basically 3 rectangles out there that are all acting the same. Okay? Yeah. Now, I haven't actually played this through to get it so that you can actually see.
So you don't have a high score yet?
Well, there's different levels in that. It actually gets different, harder, better, stronger, faster, whatever. And that was added in there as well. And I didn't get too far into that. But let me show you the moment you've all been waiting for. That you didn't know that you were waiting for it, but you are waiting for it.
Yeah.
This is the completed game that I have. And what we have in here, let me go over here and show you the code real quick. That was a sprite. That was a full screen sprite. That was the size of the screen. It's called Explosion. Grand Explosion, sorry. Because we had little explosions eventually when I finish this, if I ever decide to. And then we had the Grand Explosion, which basically flickers on the screen. Okay? So any questions about this?
I could see doing like a Tetris or something in this, but there's examples out there.
There are examples of Tetris. There's actually one commercial game called Galcon, which was initially written in Pygame. I'm not entirely sure if it still is or not, but it was part of a Py week at one point. RenPy is also written in this. Now,
So if you have 12-year-olds programming this, right, by the time they get ready for professional work, they'll be able to do, who knows, all kinds of fancy things, right? This is
Yeah.
advanced stuff.
I mean,
for-
basically,
Concepts you're teaching them,
yeah.
you know, and events and interactions.
This is my Py Week entry many, many years ago. It's available on GitHub as well.
So
You're out
spraying the
of
bugs.
crap.
Yeah, you just get to
Practice.
spray the bugs. And this is using basically everything that I showed you before. This is a sprite. These little guys are sprites. The sprays are each squares that fade out. They're alphas. It happens to have the sound and other components of a more complete game.
Sure. Uh-oh, the flowers are dying.
Yeah. And just to give you some insight too on, you don't necessarily have to use this for games. It doesn't have to be, some kind of Twitch fest or something like that. You can also use it for other things. This is something that I wrote as a photo booth for someone's wedding. What you do, you have a giant canvas right here, a surface, which is taking camera input using Pygame camera. Yeah, this is all in a sprite overlaying it. That is a font that's being rendered up there using a sprite as well. I'm really sprite happy. I write a ton of sprites. So anyways. There's several things going on here. That's a sprite up in there as well. And the flash is a full screen sprite that dims out. There's another trick on here. It takes 2 pictures on it. It takes a ninja shot. Now you know. And knowing is half the battle. Any questions?
That's very cool.
Yeah, that's really cool.
Yes?
Are card games easy?
Card games may be a little more difficult because you have to write the interface for doing drag and drop. If I were to do a card game, I would probably do something that actually had like mouse and other assorted, I mean not necessarily mouse, but some kind of
Click
GUI,
interface?
yeah, to it. They would handle buttons and that type of stuff and do drag and drop. Because otherwise you have to program all that stuff yourself.
May I have your attention, please? The time is now.
But it is all available online on my GitHub address. Just look for Craig Maloney.
When's the next 30 minutes when the hurricane is shut down?
Yes.